redox reaction. Okay, so basically under redox reaction, of course, you know the definition of redox. Definition of redox means oxidation and what? Reduction take place, okay, at the same time, right? So one of the things you need to be able to identify is to define reduction, okay, in terms of what? Gain of electron, while oxidation is defined in terms of what? Loss of what? Loss of electron. So this is called electron transfer. When you're asked to define in terms of electron transfer, okay? So oxidation is the loss of electron, reduction is the gain of electron. So oil-rich, okay, or oxlo-reducer, okay? So oxidation is the loss, reduction is the gain of electrons, okay? So of course, you know that oxidation also has to do with addition of oxygen, while reduction is removal of oxygen, right? But we are sticking with this definition of electron what? Electron transfer, okay? So those are the three ways you can define this or identify your redox. Number one, in terms of addition, okay, or removal of what? Or removal of oxygen. Or two, in terms of electron what? Electron transfer. Okay. And three, in terms of oxidation what? Oxidation number. In terms of oxidation number. So you could actually look at that. So I'm going to, this one is easier to identify. I mean, addition of removal of oxygen. So we'll look at these two together. Oxidation what? Oxidation number. So let's see how we can identify oxidation and reduction reaction, okay? So another thing you need to know apart from definition, you need to be able to identify half equations. Half equation, oxidation half equation and reduction what? Half equation. And you'll be able to tell us, okay, oxidizing agent, okay, and what? Reducing agent. You must be able to tell us which agent is the oxidizing agent and which agent is the what? Is the reducing agent. So let's look at an example of a reaction. So we'll use that to exemplify definition, okay, to identify species that is reduced, that is oxidized, to identify oxidizing agent, reducing agent, and to identify oxidation half equation and reduction half equation, okay? So let's see this magnesium, for example, okay, plus hydrochloric acid, okay, is going to give us magnesium chloride plus what? Plus hydrogen, okay? Okay, now if you look at this, we'll want to find out which species, okay, is oxidized, which is what? Which is reduced. We want to find out which equation represent or which direction represent reduction and which represent what? Oxidation. Okay, so your knowledge of ionic chemistry or ionic compound will help you very well here. See that if you look at this magnesium, what charge is it carrying? It's carrying the charge of what? 0, right?
Yes.
So here, hydrogen here, this is aqueous. Hydrogen is H plus and what? Cl what? Minus. That is you writing ionic equation for a particular reaction. So hydrogen here has an oxidation number of +1. While chloride has an oxidation number of minus what? -1. Now magnesium in here, your ionic compound is Mg2+, while this is Cl what? Minus, like 2Cl minus. So magnesium here has a charge of what? +2. While what? Chlorine or chloride, sorry, still has a charge of -1. Hydrogen here is 0. See, when a substance is in its element form, its oxidation number is 0. See, magnesium is just magnesium. Oxidation number is 0. Okay? Hydrogen here is 0. You can see hydrochloric acid. The sum of the oxidation number of all this is 0. Okay, everything like this is 0. See, everything like this is 0. Everything like this is 0. Everything like this is 0. So this is 0. So how come this? We have 2 Cl minus, that is -2 + 2. That is 0. So everything is 0. Here, +1 - 1, it gives us what? 0. Why magnesium is what? Is 0. So that's another way to look at what? Oxidation what? Number. So having looked at this, let's now see oxidation. Oxidation is the loss of what? Electron or increase in oxidation number. So let's trace magnesium. Magnesium move from here to here. It looks as if it moved from 0 to +2. That is an increase in what? Increase in oxidation number. That's an increase in oxidation number. So we call that what? Oxidation. Okay, we'll still establish this using what? Electron transfer. But you can see magnesium move from 0 to +2. That is an increase in what? Oxidation number. So in terms of electron transfer, let's look at that. Magnesium, of course, you know metals can lose electron, right? Magnesium is in group 2. It's going to lose 2 electrons to form what? Magnesium ion. So you can see loss of electron is oxidation. So it means that this is the oxidation what? This is the oxidation half what? Equation. That's the oxidation half what? Equation. Okay? Oxidation half equation. Magnesium has lost electron. So looking at it in terms of electron transfer, we can see this is in terms of electron what? Transfer. Oxidation is loss of electron. This one is in terms of what? In terms of oxidation what? Oxidation number. You can see. So we can look at it in these two ways. In terms of electron transfer and in terms of what? Oxidation what? Number. So let's check again. We have, this is hydrogen ion, right? Hydrogen moves from what? It moves from +1 to what? To 0. That is a decrease, isn't it?
Yes.
Right?
Yes.
Okay, decrease in oxidation what? Oxidation number. Okay, so of course, decrease has to do with reduction. Decrease means reduction. But in terms of electron transfer, let's look at it. What?
Because I thought you said oxidation is loss, reduction is gain.
Yes, reduction is gain of electron. Gain of electron, not just gain of electron. Or reduction is decrease in oxidation number.
Okay.
You got that right?
Yes.
So we are looking at it in two ways. In terms of electron transfer, in terms of oxidation number. Okay, so when you have you have a big picture of these two perspectives together, it helps you to easily identify your oxidizing agent and your reducing what agent. Okay? Because if you don't break it down into ionic form like this and there are charges, you might find it difficult to know, okay, which one lost electron, which one gained electron. Okay? So let's look at it in terms of, so let's look at the reduction half equation. Reduction half equation and see what we're going to get. Reduction half equation here. So your hydrogen ion plus, what happened to hydrogen ion? It gained what? Electron, right? To form what? To form hydrogen. Hydrogen is diatomic, so I'm going to be having what? 2. So multiply this by 2, then this is 2. So you can see hydrogen ion gained electrons to form what? To form hydrogen molecule. To form hydrogen molecule. Okay, so you can see reduction half equation, oxidation what? Half equation. Any question?
No, sir.
Okay, so the next thing is, okay, can you identify the reducing agent and the what? Oxidizing agent. Identify reducing agent and what? Oxidizing agent. So a reducing agent, to be able to identify that, I'll still use the same example. It is magnesium plus what? Hydrochloric acid to form what? Magnesium chloride plus what? Plus hydrogen. Okay, and we know, we have looked at the first equation. We said magnesium, okay, formed magnesium 2 plus 3 minus. Why? We said that your hydrogen ion, okay, 2 gain 2 electron to form what? To form hydrogen. Okay, so we said this is the oxidation half equation. Why this is what? This is the reduction what? Reduction half what? Half equation. So if that is the case, the situation here, then what is the oxidizing agent? Okay, so you need to look at this. Oxidizing agents, okay, oxidizing agent becomes what? Becomes reduced. Okay, why reducing agent? Reducing agent becomes what? Becomes oxidized. Okay, oxidizing agent becomes reduced, while your reducing agent becomes what? Oxidized. Now, they sound confusing and opposite. Now, this word oxidizing here, okay, ing here, does not mean something that is oxidizing. Okay, look at that word agent. It helps you to understand that what does an agent do? An agent causes something to happen. An agent causes something to happen. So therefore, an oxidizing agent causes oxidation to happen. So when you say oxidizing agent, we're not saying that itself is being oxidized. No. Okay? Oxidizing agent causes something else to be oxidized, but in the process, itself becomes reduced. So a better way to look at it so that you don't get confused is to say oxidizer and reducer. So an oxidizing agent is an oxidizer. It causes oxidation to happen. It doesn't mean that itself is becoming oxidized, no, because that is what the word English, that English word will connote. When you say oxidizing agent, it means an agent that is oxidizing, that is getting oxidized. No, it is an agent that is oxidizing another agent. So oxidizing agent is an oxidizer, while a reducing agent is a reducer. Okay, so if you look at it that way, a reducing agent is a reducer, you won't get confused. So a reducer gets oxidized, while an oxidizer gets what? Gets reduced. I mean, it's basic. It's basic. So let's assume that this is Tolu. Okay, you have your on your left hand you have 2 coins, and your left, this is your left hand, this is your right hand. On your left hand you have 2 coins. On your right hand you have no coin. Now, if your left hand gives your right hand a coin, what will happen to the number of coins on your left hand?
Can you say that again?
I said, you have two coins on your left hand and you have no coin on your right hand. If your left hand gives your right hand, okay, a coin, what will happen to the number of coins on your left hand?
It reduces.
It reduces. Okay, good. So your left hand is making your right hand become better. Your left hand is oxidizing your right hand. Is oxidizing your right hand. Your left hand is the oxidizer. But in the process, what happened to it? It becomes reduced. It becomes reduced. While your right hand, okay, is a reducer. Obviously, your right hand is the one collecting from your left hand. So your right hand is a reducer. But what happens to your right hand at the end of the day? It gets what? Oxidized, because your right hand becomes better. So at the end of the day, I will have the coins on my left hand will now be on my what? Right hand. So I'll say my right hand has been oxidized. Okay, but why? Because my right hand reduces my left hand. My right hand is the reducer. My right hand is the reducer, while my left hand is the oxidizer. So at the end of the process, my left hand has become reduced, while my right hand has become what? Oxidized. So oxidizing agent becomes what? Reduced. While reducing agent becomes what? Becomes oxidized. Reducing agent becomes what? Oxidized. Okay? That's simple. Then the opposite will be your what? Oxidizing agent becomes what? Reduced. Okay? While your reducing agent becomes what? Oxidized. Okay? So, good. So now let's apply this knowledge to this. So between magnesium, okay, between these two reactants, this and this, which is your oxidizing agent?
Hydrogen.
What?
Hydrogen.
Hydrogen? No.
Oh, hydrochloric acid rather.
Hydrochloric acid, or you say hydrogen ion. Hydrogen ion, okay, or hydrochloric acid, because hydrogen is a product, not a reactant. That is where students get it wrong again. Okay? Your reducing agent is what? Yes. Hydrogen ion, or what? Hydrochloric acid.
Okay.
Good. Why your oxidizing agent is what? Magnesium. Magnesium. Okay? So in redox reaction, you must be able to identify reducing agent and what? Oxidizing agent. Okay? So let me see what you can do with this. Okay? You have a reaction between aluminium and ion 3, aluminium and ion 3 oxide. Complete the equation, and number one, you write the A, oxidation equation, half equation if you like. B, the reduction equation. Then number two, you're going to identify A, the oxidizing agent, and B, the reducing what? Agent. Okay?
Okay.
Yeah. So go ahead with that. Let's say in 2 minutes it should be done.
So wait, when you're writing an oxidation reaction, equation,
Yes.
I just write how many electrons aluminum gains for example, the oxidation, and how many iron loses for the reduction.
Okay. When you are writing the oxidation half equation, right? Your aluminum, yes. How many electrons will it lose or gain? Then what is it going to form? Do you get that?
Okay. Okay, so let me first say the oxidizing agent and reducing agent. The oxidizing agent in that one, in this equation, is the ions.
The iron.
The iron ions.
Okay.
And the reducing agent is the aluminum ions.
Okay, the reducing agent is the aluminum ion. Okay. Correct.
Then is for the oxidation equation, is it Al plus 3E?
Oxidation is what?
Oxidation in terms of oxidation numbers.
Oxidation is what?
Oxidation is loss, reduction is gain.
So then, but you said aluminum plus.
Sorry. Fe 3 minus arrow.
Okay.
Fe plus
Okay, take that again. You have your, okay, you must have written this first. Al2O3 plus what? Fe 3 plus, right?
yes, 2 plus.
You can balance the equation, okay, 2, okay? So now, oxidation half equation, you say Fe 3 plus, yes.
Arrow.
Okay.
Fe plus 3 plus 3E.
Okay, good.
Reduction one is Al plus 2E minus.
Okay.
So plus 3E minus. Arrow Al 3E minus 3E wait. Al 3. But the valency for Al is 3 plus.
Yes.
So is it Al 3 plus?
Al3 plus.
Plus.
Okay, you are saying that your aluminum will gain. Is that what you are saying?
Oh, I see what you've done. Okay.
You are saying your aluminum will
Give me a
gain?
second. Yeah, aluminum can't gain, it only gives away, doesn't it?
Okay. So your oxidation is loss of electron. So oxidation is a loss of electron. You already told us that, you already said that aluminum is what? What agent is aluminum?
Reduction.
What agent is aluminum?
It's the reducing agent.
Aluminum is a reducing agent. Okay. So what then? Which one is the oxidizing agent?
Iron.
Ion.
Ions.
Okay, ions. Okay, so therefore, if you look at this, then this equation should be this. Okay.
Okay.
Good. So ion, right? So these are your reactants. These are your reactants. Okay. Your ion is your product. Ion is a product. This ion is your reactant. So you either say this or you say ion what? Ion 3 oxide is your oxidizing agent, or ion 3 ion or aluminum. Do you get that?
Okay.
So then your oxidation now, oxidation equation, half equation will be oxidation is the loss of electron. Loss of electron. So now you look between aluminum and ion, which one loses electron? Huh?
Hello?
Between aluminum and ion, which one lost electron?
Aluminium.
Aluminum. So we have Al, okay? Yes, it's going to lose electron to form Al3 what? 3 plus, so plus 3 minus, okay? While your ion 3
Okay.
plus is going to gain 3 electron to form what? To form ion. You can see that. So we definitely can always balance the equation. We can balance the equation looking at, yes, we can always balance that equation. If you want it to look exactly like what you have here. So basically we can have your 2 aluminum, okay, 2 aluminum plus 2 Fe3 plus, okay, it's going to give us what? 2Al3 plus what? Plus 2Fe. Okay, so that would be the overall ionic equation. Okay, the overall ionic what? Ionic equation, or redox equation, if you like. That's overall. So why are we not showing oxygen? You know, here it will be O2 minus 3. Yes, and here too, we have O2 minus 3. But we are not showing this because oxygen ion remains unchanged. So oxygen ion is called a spectator what? The spectator ion. Okay, spectator ion in this reaction. So it remains unchanged. The valency or the oxidation bar remains unchanged. So you call it a what? A spectator ion. Okay, it is spectator ion. So it remains unchanged. So usually in your overall ionic equation, you remove your spectator ions there. Do you get this?
Yes, I get this.
Okay, so let me give you a final one. Let's take a metal. Now zinc plus copper sulfate. Zinc plus copper sulfate. Okay, so yeah, zinc sulfate plus what? Plus copper. Okay, so find the oxidation equation. Oxidation. Okay, find the reduction equation. Then state the oxidizing agent. State the oxidizing agent. And D, the reducing what? using agent. Okay, so go ahead. This time around, get it right.
Okay. Reaction is, okay, let me. Okay, Zn plus, no, Zn arrow. Okay, Zn arrow, Zn plus 2e.
Okay. Zn.
And
Zn plus 2e.
yeah, give me a second. Let me. Zn2 plus 2e. Yeah.
Okay. Zn2 plus. Okay.
The reduction reaction is Cu 2 plus 2e. To make C, the spectator ion is SO4.
Okay. Okay, so we can combine everything together to give you your overall equation. I think you're fine. You're fine with redox. Okay.